Hello everyone. Welcome to our another video in the series on mastering data structures and algorithms. I'm Dr. Prashant K. Gupta. The topic of today's video is multidimensional arrays. Uh, This is a brief introduction about me. This is the link to my website, and by passion, I'm a researcher and a teacher. So first of all, what are multidimensional arrays? The arrays that we have discussed so far are one-dimensional because there is linear variation in the data values of the indices that are there in the array. However, it is also possible to have multidimensional arrays. A special case that we'll be discussing are the two-dimensional arrays. This is an example of a two-dimensional arrays where the data values are organized in the form of rows and columns. Say suppose in a two-dimensional array there are m number of rows and m number of columns. So the organization is like this into m number of rows and along this in the form of n number of columns. An example is shown over here of an array that has 2 rows and 3 columns. Now the idea is the values now will be referred by two indices. The first index corresponds to the row and the second index now corresponds to the column number. Therefore, the first element is A11, that is the element in the first row and first column. A12 is the element in the first row and second column. Similarly, A21 means the element in second row and first column and so on. Therefore, there will be m into n total number of elements, where m is the number of rows and n is the number of columns. So over here, this value comes out to be 6. However, this is a logical representation. In the memory, the two-dimensional arrays are not represented like this. They are represented either in the form of row major order or column major order. So let's see how that is done. In case of a column major order, we begin from the first element of the array, that is A11, which is also called, the address of A11 is also called the base address of the array. And we start scanning column wise and keep on storing the elements in a linear array till the time we have traversed through all the elements of one column. Then we start with the second column and keep on going downwards till we have scanned all the elements of the second column and so on till we have scanned through all the columns and all the elements have been stored in an array. So like you can see over here, first of all, the first element to be stored in the form of linear array is A11. Now going column wise downwards, the second element is A21. So it is the second element to be stored in a linear array. Since we have scanned through all the elements of first column, now we'll start scanning from the second column. Now similarly, A12 is the third element to be stored in a linear array and so on till the time we reach the last element, that is A23. So now you can clearly see that the number of elements in any kth column is equal to m, that is equal to the number of rows. Over here, m is 2, so therefore in any column there are m number of elements. As opposed to this, in a row major order, we start with the first element, that is A11, and keep on progressing along the row till the time we have scanned through all the elements in a row, and then we start progressing from the second row and so on till we reach the last column element, last row and last column element. Over here, A11 is the first element to be stored in a linear array. Now progressing along the row, A12 is the second element that we encounter, so that is stored at second index and so on till we reach A23, that is the last element to be stored. Now an important point to note over here is again the number of elements in any jth row is equal to n, that is equal to number of columns. Like you can see over here, in the first row there are 3 elements, that is equal to the number of columns. Similarly in the second row, and that is true for all the rows. Now a common challenge that these students face is finding out the location of any ajkth element within an array, either going by the column major order or row major order. So let us see each of these cases one by one. Now as we know, the column major order progresses starting from the first element and the progress goes downwards till we have scanned all the elements in one column. Then we switch to the next column and so on. So before reaching ajk, we would have gone through j minus we would have gone through k minus 1 columns and some elements in the jth row. Let's see how. Now, as discussed before, in the column measure order, all these values will be stored in the form of linear array, where b1, that is the element at the first index of array b, will be a11. Then the element at the second index will be a21, that is this, and so on. So now you can clearly see, before reaching aj k, we would have gone through the k minus 1 columns, and since each column contains m elements, so therefore total number of elements that would have scanned through will be m into k minus 1. In the before reaching the jth row, inside the kth column, there will be j minus 1 element. Therefore, the location of ajk, which is equals to L inside the linear array B over here, is given by the base address plus number of words per memory multiplied by m into k minus 1 plus j minus 1, because this is the number of intermediate elements that we would have gone through before reaching this element ajk. Similarly, going by the row measure order, now you can see we begin from a11 and keep on progressing along the row till the time we reach the jth row where this element ajk is found. So again, the challenge is we will be storing the elements starting from a11 going along the row in the form of a linear array, where the value stored at first index will be a11, that is at b1, value stored at second index b2 will be a12 now, and so on. So progressing in this way, we would have scanned before reaching ajk, we would have scanned through j minus 1 rows, that is the row just above the jth row. And since each row contains n number of elements, which is equal to the number of columns, therefore the total number of elements you would have scanned through will be n into j minus 1. Further, before reaching ajk inside the jth row, we would have scanned through k minus 1 elements. Therefore, the location of ajk, that is equal to the base of a plus number of words per memory multiplied by n into j minus 1 plus k minus 1, because these many number of elements will be scanned through starting from a11 till the time we reach ajk. Next is the concept of generalized multidimensional arrays, where the third dimension actually denotes the page number. As you can see over here, this denotes the row number, this denotes the column number, and now the third index denotes the page number. So you can see all the elements on page 1 have the third index value as 1. After scanning through page 1, the next element that will be stored will be on page 2. So now you can see the row number and the column number remain same for the respective elements. Like over here, the first element on page 1 is A111, first row, first column A11, and since on page number 1, so third value is 1. However, only difference comes in over here, where the third value becomes page, being on page 2, the third value becomes 2. Similarly, after page 3, next element can be onto page 3, and so on. This is how the values are organized in the form of multidimensional arrays. So thank you all for watching our video, and don't forget to subscribe to our channel for more and more good videos that will coming up soon. Thank you.